This is GMAETS 41. You are welcome to question number 8 of our U-Substitution integration problem. I hope you're enjoying this adventure, this campaign on U-Substitution. Always stay tuned. There is a reason why I am giving this special attention to U-Substitution problem. And this reason I am going to tell you when we hit our 15th question. Always follow through so you get to understand why we are doing this, undertaking on this adventure. We have other techniques of integration. Some of you are already asking some question on this technique and other things. I have full lecture videos on all these techniques of integration already. Make use of this channel's playlist. Go to MET 101/102 and you would see the lecture videos on all these techniques of integration. Of course, other topics that you are dealing with in your courses. Okay, like I said, in question number 15, we are approaching it already. Okay, we are getting close to it. I will tell you the reason why I decided that we undertake this adventure on U-Substitution. Come along with me, please. Let's solve this question number 8 quickly. Now we have integral 7 square sec 5x tan 5x dx. How do we deal with this? Remember, these two functions are being multiplied, square sec and tan. I told you that whenever you are to integrate terms that are being multiplied, quickly check if you differentiate one, will you get the other one? If that is the case, then product U-Substitution will solve it. Where you add 1 to the power and divide by the power of that term, that function, which if you differentiate, you get the other. Looking at what I have here, if I differentiate tan 5x, it will produce square sec 5x for me. Take a look. Differentiate with respect to x, tan 5x. This is what it's going to give to you. It's going to produce 5 square sec 5x. So you see clearly that you have this square sec 5x, which is what you have here. Which simply means to integrate this term, we are going to go to tan 5x, add 1 to the power, and divide by the power. But hey, observe, when we differentiated tan 5x, there was this constant difference that was produced. It didn't give us 7 square sec 5x. By the way, this 7 has to be pulled out of the integral sign, you know that. Yeah, and if you remove it, you're going to get 7 integral, then square sec 5x tan 5x. Because usually we don't integrate constant, so we bring it out of the integral sign. So coming here, when we differentiated this tan 5x, it produced a constant difference of 5 from what you have here. What do you do with this 5? It's going to be the denominator of your solution. We made something like that under quotient U-Substitution. So this is what we are saying here. This 7, write it as a constant, then over this 5. Because this 5 is what made the difference between the derivative of tan 5x and square sec 5x. Besides, you obtain the square sec 5x in this case. So you have to account for this 5 that produces a difference, which will come as a denominator. Now move to tan 5x, which you differentiated to produce this square sec 5x. Add 1 to the power and divide by the power. So you are going to get square tan 5x over 2. Remember, the power of this tan 5x is 1. If you add 1 to it, it will be power 2. Which is written as square tan 5x, then over 2. So in conclusion, we can say that the integral is now equal to 5 times 2 is going to give you 10. So 7 over 10 square tan 5x plus c. And this, of course, is our solution. I hope you enjoyed this solution. And if you've been following through the series of our 15 questions on U-Substitution as we are moving on this adventure, you would say that this is 1 plus 1. I look forward to seeing you in question number 9.